All right, here we go. First one of the year. You ready, Sorensen? How's this for your opening definition of your 8th grade year honors geometry? An undefined term. Wow. A term with no fancy definition. An undefined term is something that we can define more using a picture than other maybe geometric words that we'll get into later. So 3 of the undefined terms that we're going to talk about, and these are going to come up pretty much all year. A point, a line, and a plane. Did you ever think it was going to be that tough the first day, Roman? Huh? Okay, point, line, and plane. So an undefined term doesn't have a fancy definition. It's easier just to look at a picture, a point. Hey, there it is. You guys have been dealing with points for a long time, so I'm not going to spend too much time on it. Now, is a point, how many dimensions does a point have? Is it 0-dimensional, 1-dimensional, or 2-dimensional, or 3-dimensional? What do you think? Donnelly? 1-dimensional? When I think of dimensions, I think of a cube. Okay? Why is a cube 3-dimensional? It has a blank, and a blank.
A length, a width, and a height.
It's got a length, a width, and a height. That's 3-dimensional. So, how many dimensions does that have? That's 2-dimensional, right? It's got a length and a width. Well then, what would that be? It's got a length. So, well, that wasn't a very good dot. So what's that? 0 dimension. Okay, so a point technically has no dimension. It's just represented by a dot. Okay. Theoretically, it has no dimension. But then we talked about a line. A line, well, it has a length. It has 1 dimension. And it's represented by a line. Oh, wait, how can you have the word in the definition? To make it a line in geometry, there's a lot of different ways you can talk about a line. A lot of people say this is a line. Okay, actually, this is not a line. When we're talking geometrical, a line, you need to throw the arrowheads on there. Bam, bam. And what does that signify? What do those arrows mean?
Never ending.
Never ending. That sucker goes on forever. Willard, never find the end of that rainbow, okay? Not going to find that pot of gold. Okay. Now, a couple little technical points. Through any 2 points, there's exactly 1 line. I don't care how hard you try, Hager. Between points A and B up there, there's only 1 line. Okay, you can't bend the rules like Avatar and go, well, there's a line. Sorry, that's not a line. It's curved. A line is straight. You can use any 2 points on a line to name it. So there's a lot of different ways to name a line. It's a little small up here, but you can see it better in your note-taking guide. You can call it by its name if it's got a label, like line L. Oh, that's fancy. Line starts with L. They named the line L. That's great. But you could use different letters too. If you have multiple lines, you might call one P, R, Q, S, T. It doesn't matter. Okay. You could call it line AB. And notice how they write it. Just how we talked about a line, you need the arrows to signify that it goes on forever. When we label it, we could write AB with the little arrow above it. Or you could call it BA. It doesn't matter. Order's not important. That's kind of a nice thing about geometry. All right, so let's keep cruising here. A plane. I wish you guys ever see that show from the 80s, The Plane, you know what I'm talking about? The little guy on the island. I think it's called Treasure Island. I don't know. I'll try to YouTube it. If I can ever get YouTube, it's kind of funny. This little guy sees a plane go over the island. He's like, plane. Nah, whatever. Okay, wrong type of plane, right? That's a plane that's in the sky. We're talking about a plane. And the way I think about a plane, it's like the floor. If you look at the floor, it's just a big flat surface. Okay, a plane has, we talked about it earlier, 2 dimensions, represented by a shape that looks like a floor or a wall. It doesn't stop though. We don't throw arrows on it, but a plane technically goes on forever. Okay, it's like a huge football or a soccer field. Through any 3 points on the same line, They're exactly one plane. So you need 2 points to make a line. You need 3 points to make a plane. Okay. How come I couldn't just do it with 2 points? What do you think? Imagine these are points. Why couldn't I build a plane with just 2 points? Come here. TK, you're the plane, huh? Okay, here's my 2 points. Show me a plane that goes through those 2 points. Let's just pretend like the very tips of these markers. Okay, there's a plane that goes through those 2. Can you give me another one?
No.
What if, now instead of holding the paper vertical, what if you held it horizontal? Okay, that's still kind of going up and down. Can you flatten it out for me? There's another plane that goes through the 2 points. Can you make the paper diagonal for me?
Wait.
There you go, right? So you made 3 different planes that went through 2 points. There's an infinite number of possibilities. Thanks. There's an infinite number of possibilities if you only have 2 points. That's why you need a third point to define where a plane is. So you can use 3 points that are not on the same line to name a plane. All right, what do we got next here? Oh boy, a lot of definitions. How can we shorten this up? We don't have to write all this down. Let's just talk Greek roots here. What does the word co mean? Co-pilot. You've got one pilot, blank another. Assisting. That's a really fancy word for it. Co. Rouse? These are 2. With. Okay? So if 2 things are collinear, they're on the same line. Okay? They share the same line. Coplanar. With. They're with each other on the same plane. So, I mean, if you want to write these down, you can. I'm not going to spend too much time on them. Co, maybe you just got to remember with. Root word. Defined terms, you don't have to write that definition down. We put undefined terms, right? They don't have a fancy definition. Well, a defined term, it's more fancy. These are terms that we can describe with other geometric terms that we know. Now that we know what a dot is, a line and a plane, well, we can use those 3 words to help us define some other things. Like a segment. Okay, somebody tell me, I'm going to cover that up. Somebody tell me what they think a segment is. How does a segment differ from a line? Donnelly. Yeah, a line goes on forever. A segment, let me see if I can find my right tool here. Let me get rid of this. A segment, like Donnelly said, bam, it's got 2 endpoints. Okay, 2 endpoints. And I'm going to call this this point A and this point B. What do you think we could call that segment? If we were naming it.
Segment AB.
Segment AB. Anybody got another name for it?
Segment BA.
Beautiful, segment BA. Okay, and if we write it, you know how with a line we put those little arrows above it. What do you think we put for a segment?
Dots.
Yep, and we don't even have to put dots. We can just go like that. We just draw AB, or we could put BA, and we just put a little line above it, and that talks segment instead of a line. So, not too bad there. All right, let's keep cruising here. Array. What's array? I had array in class last year. Ray Novi. Played middle linebacker for the Baltimore Ravens. Roman.
Well, like, half it's a line and half it's like a segment. Like, there's one point and then the other part continues.
Very good. Has one end point and the other part continues. So if I draw a picture, you know what, I wouldn't even worry about writing the definition. I think it's easier to write it with a picture. Just like he talked about, how come I can't get my, there we go. Okay, array. It's got one end point and the other side goes on forever. Now how do you think we could name, we need 2 points to describe a line or array or anything like that. Let's call this M. And this N. What do you think we could call that thing? Farley.
MN.
Ray MN. Okay, Ray MN. We'd say MN. And what do you think we put above it? A line has 2 arrows. A segment's just a line, a little without the arrows. What do you think?
A line with one arrow.
Yeah, a line with 1 arrow. Is there anything else we could name that thing? Lind.
Ray WM or NM.
Okay, so here's the question. Can we name this thing NM like that? What do you think? What do you think, Andrew?
Got to go the other way.
Have to go the other way. It does matter with array because when you say MN, what letter am I starting with? M. I'm starting at M and I go on to N forever. Why wouldn't NM work? Yeah, if I started at N and I went in the direction of M, it would go on forever this direction, but it doesn't. It stops at M. So, you know, it's just one of those little nuances with rays that we got to think about. Opposite rays, hey, they're just rays that go in the opposite direction. So I might have something like this. Again, if you don't want to write the definition, you don't have to, but it might be something like this. Well, there's a line. I'm just going to put a couple points on the line here. Boom, boom, boom. I'll call it A, B, and C. Anybody think they could tell me what opposite rays are? Rays that are on the same line, starting at the same point, but they go in opposite directions. What do you think? Don's? BC and BA. Yeah. They start at the same point. They both start at B. One goes in the direction of C. The other goes in the exact opposite direction. It goes to A. So, just little vocab terms. I like using pictures sometimes better than defining them. Intersection. Hey, the intersection of County Road 50. You guys hear about that? Big roundabout going in. County Road 50 and 185th Street up by Century and Target there, northern Lakeville. Big roundabout going in at that intersection. Well, what's an intersection in roads?
Two roads cross each other.
Yeah, it's when 2 roads cross each other. Bam, there's a road, there's a road. Hey, there's the intersection. So when 2 lines intersect, what do they make? When 2 lines intersect, where do they meet? At a point. We're defining intersection with some things, undefined terms that we know, a point. What do you have when 2 planes intersect? What do they create? Do they intersect at one point? A crash, would somebody say? A crash, yeah. They crash right here, don't they? I get a different color. They crash right here. When they crash, what do they create? A point? A line, yeah. When 2 planes intersect, they actually make a line. A whole bunch of different intersection spots. Cow. I miss numbers, don't you guys? Isn't math all about numbers, not about all these words? We've got to bear through it a little bit today because, I mean, really, these definitions are going to set the foundation for so much that we do this year. We just got to take a little time to go through them. Okay. All right, let's jump to example 1. We've already talked about this stuff a little bit. Give 2 other names for line LN. They've got a little diagram there for you. Somebody give me another name for line LN. What do you think? Yes, ma'am.
Line B.
Line B, look at, they labeled it. So we could say B. Anybody else think of another name for line LN? Yeah?
Line NL.
Line NL. And if we're going to label it that way, we just have to put a little arrows above it. How about another name for plane Z? They labeled this plane Z. You need 3 points to determine a plane. So how do you think you could, what's another name for plane Z? Anybody see 3 points that would help us make it? Yeah. What was it? NPL. There's 3 points on the plane. So we could call it plane NPL. Anybody got another one? Farley?
MLP.
Oh, look at you, stinker. NLP, huh? Order doesn't matter. They look different, but it's the same plane. Okay? Give me 3 points that are collinear. They're with each other on the same line. 3 points that are collinear. Dons.
L, M, and N.
L, M, and N. They're collinear. They're on the same line. They're with each other. Give me 4 points that are coplanar. They're with each other on the same plane. Coplanar. Boyd.
L, M, P, N.
L, N, L, M, N, P, or L, M, P, N. Yeah, they're all on the same plane. L, M, N, P. Make sure I got my alphabet down there. Yeah, they're with each other. That's not so bad. Okay, we're going to skip this checkpoint problem. You guys got this down pretty well. Let's jump to example 2. Okay, now we're getting into more of that segment, ray stuff. Give another name for, well, what is this? How do I read this? Yes, ma'am?
Segment VX.
Good, segment VX. Give me another name for segment VX. Another segment. Yeah, Roberts.
Segment XV.
Segment XV. That works. Are there any others? Not really, because a segment really is defined by its 2 endpoints. X and V, V and X, those are the 2 endpoints. Those are the ones I have to use. How about give me all the rays that have the endpoint W? Okay, give me one, Dons.
Ray WY.
WY, yep. Make sure I put my little label above it. What else we got? I need another ray. Yep.
WX.
WX. Hager?
Ray WZ.
WZ. Ray WZ. Linsky?
Ray WV.
WV. Yeah. The key is, ray, if it has an endpoint of W, it always has to start at W. And you guys did that in each example. Very good. Now, a little tougher definition, but still not too bad here. Give me opposite rays. Which ones are opposite rays? What do you think? Taking a look at that. Farley, what do you think?
Ray WV and WX.
So WV goes this direction. WX goes that direction. They have the same endpoint, go in opposite directions. I agree. Okay? So he said WV and WX. Anybody see another set of opposite rays up there? Weber, what do you got?
WY and WZ.
WY and WZ. Good. WY and WZ. So you see a lot of today is just foundational definition stuff. Let's keep cruising here. We're not going to do the checkpoint problems. You guys have this stuff down. We just want to run through a couple examples. Okay, now this is where I would really get challenged. And I feel kind of bad. I still remember it. 6th grade, Mrs. Swanson was my teacher. Chris Watson was a good friend of mine, and he was really good at art, and he wasn't so good at math. And I was good at math, and I was really, really bad at art. So at this point in time, I would have him do my art homework, and I would do his math homework. I'm not advocating that at all, okay? But this is where you get an opportunity to kind of test your skills. Sketch a plane and a line that intersects the plane at more than one point. Okay, see if you can draw one of those. See if you can draw that. All right, so let's take a look at this. Sketch a plane and a line that intersects the plane at one point. Got a plane, right? Not an airplane. Got a line. Am I ever going to be able to take that line and intersect the plane like this in more than one point? No. Doesn't matter how I work my line. No matter how I work the line, I can only hit this in one spot. What's the only way I could hit it in more than one spot? What do you think, Don? What's that? Put it diagonally like that? In a different spot up here? What do you think? Could hold it like this. God, no matter where I put that thing, I'm only hitting it in one spot unless I do what? Brady? Bend it, but then it's not a line. But you're getting close. You're getting there. You're getting close. What's the only way I could get this line to hit this piece of paper in more than one spot? If the line is blank the plane.
Parallel.
Parallel or on it. Heck, that's the only way I can do it. If I took that, it only hits one spot, 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 boom, until I'm with the plane, until I'm on the plane, and then it hits how many spots? Yeah. Actually, there's an infinite number, right? It hits it in an infinite number of places. So if we wanted to draw something, it might look something like this. I'm going to start with the plane. Okay. And then I'm going to just make a line, maybe something like this. Okay, and it said goes through more than one point. Okay, A, B. There. It doesn't have to be pretty. You guys can see that my talents don't rest in my art ability, but we get the gist of it. Okay, sketch a plane and a line that is in the plane. Sketch a plane. Okay, I can do that. Just like a piece of paper. And a line that's in the plane. Okay, I can do that. That's not too bad. Sketch another line that intersects the line and plane at a point. There's a lot of different possibilities, right? We just need another line. How many spots does it intersect? Intersects at point. That's all they're asking for. Now this one's kind of a unique situation because what if I would have asked you, let's see if somebody can create this, okay? What if I would have asked you to make a plane with a line in it? Okay? Make a plane with a line in it. So that would be our situation like this. And then I said, draw another line, hold it down, draw another line that intersects the plane and your line at only one point. If I did it like this, it intersects the line at one point, but it hits the plane everywhere, right? There's an infinite number of hits. What would I have to do to only hit in one point on the plane?
To get like inside the
Show us.
top, maybe.
Yeah, good. Take out your aggression on it. There. That would be an example of, okay, I've got a line in a plane, and I've drawn another line that intersects the plane only once and intersects the line once. So it's kind of, geometry is a lot of three-dimensional thinking. It's kind of thinking in a little different way, but it's kind of fun at the same time. All right. We've had enough of that. Yeah, we've had enough of that. And let's do this one quick. This is a real quick one. Name the intersection of line MX and line A. Let's take a look at, this is checkpoint problem number 5. Taking a look at that diagram. Where do MX, line MX and line A, how do we describe it? At point M. Good. Point M. When two lines intersect, they intersect at a point. How about the intersection of plane C and plane D? Those two flat shapes up there, where do they intersect? Remember?
Line A.
Line A. Very good. And we don't really have another way we could name it because we weren't given another point on the line. So it's not like I could call it line M something or other because I don't have another letter on it. So we just have to call it line A. Very good. All right, you guys got your, hopefully that's the most definitions we ever have to do again this year. Looking at this for our homework, these questions are going to go real quick. It's a lot of that definition stuff.